Good afternoon, everybody, and welcome to Rail Baltica Academy session on Connected Europe and Connected Railways. My name's Andy Billington. We're going to talk this afternoon about innovation, digitalization, and the opportunities we have in a unique greenfield project, European scale project across 3 countries. We have a facility for you to ask questions and to respond to some audience polling. So if you could look at the QR code or go to slido.com with the hashtag Rail Baltica Academy, and you'll see an initial poll will go live very shortly asking about your interest in the project and sort of why you're attending this afternoon. And we'll share the results of polls after the event, but it would be great if you can share as much information as or choose some of those options while I'm going through what is Rail Baltica, and then we'll look at the results of that. Thank you. So what is Rail Baltica? As I said, this is a greenfield project. It's a completely new transport infrastructure linking Estonia, Latvia, Lithuania, and into Poland, connecting the 3 Baltic states with the European main railway network with standard gauge track for the first time in a very long time. There will be 870 kilometers of new infrastructure, double track, standard gauge, as I mentioned. We'll be using radio-based ERTMS as the train control traffic management systems, and the intention is to look at FRMCS, but I'll come back to what that is. The line will be electrified as European standards. We're taking advantage of the fact that this is greenfield to have slightly longer trains than most other places and a higher axle load. So we should be able to cope with freight trains at up to 1050 meters long and 25-ton axle loads. For comparison, many other European railways are 22, 20, or even 18-ton axle loads. So you can see we'll be able to take heavier trains, which hopefully will encourage intermodal use and the transfer of goods from road to rail. In terms of design speed, we're looking at up to 249 kilometers an hour for passenger trains, 120 kilometers an hour for freight trains. Obviously, they are maximum, their design speeds. There may be, for example, regional trains which are running at 140 to 160 kilometers an hour. We're also, again, taking advantage of the greenfield to look at the loading gauge. So the physical size of train that we can support will be a gauge known as the C gauge from Sweden, which is slightly larger than most others. And importantly, it actually has a flat top, unlike most others which are curved. So the use of space can be more efficient. So this is one way we can take advantage of the greenfield. As you can see in the diagram, there will be high speed, there should be no support for night trains, and there'll be freight and regional services. So we're connecting the ports of Tallinn at Muuga and also the passenger port in Tallinn, the airport, Pärnu, Riga Central Station, Riga Airport, Panevėžys, Vilnius and Vilnius Airport, Kaunas Airport and intermodal freight terminals, and linking through to Poland. From there, obviously, night trains could go on to other destinations and freight trains could go on to other destinations. We are the northeastern end at the moment of the North Sea Baltic corridor, which is one of the 10T corridors from the European Union's Connecting Europe initiative and transport initiatives. So obviously having the ability to connect on standard gauge is going to be very important. The interesting statistics that have come through, we have roughly 44% of you have said potential passenger, 33 potential supplier, and some general interest in the project, and a few potential future colleagues, which is always good to hear. So thank you very much for that information, and we'll go on with the impact and the possibilities that this new infrastructure will bring in terms of journeys, destinations, and so on. So in terms of journey time, Tallinn, Pärnu is currently around 2 hours. It'll become around about 40 minutes. Pärnu, Riga is currently also about 2 hours. That'll become an hour. And you'll see successive improvements. It means that Tallinn to Riga is around 1 hour 40, 1 hour 42, instead of the over 4 hours it is at the moment by road. That's a significant change. It's a step change in what it means for the infrastructure and for the people in the region. But the project is not just able to deliver rail infrastructure and passenger and freight services. The title of the presentation is Connected Europe, Connected Railway. So we can look at synergies. What else can be done at the same time as the railway is being implemented? So clearly we have opportunities for energy connections because we will ourselves need grid connections. We'll have digital infrastructure. We have the ability to put in optical fiber down the side of the track, for example. That can be coordinated across the borders, and we can help provide high bandwidth networking or high bandwidth communications between different places. Where we can, we'll look at that as a sort of dig once construction plan. So there was one set of works, not one set of work, and then a few months later somebody comes along to install optical fiber, for example. Everything should be carried out in parallel wherever we can. But the one thing to keep in mind about railways is this is long-term infrastructure. And what do we mean by long-term infrastructure? So before I was in rail, I was in the IT sector, and long-term typically means 3, 5 years, maybe 7, depending on what the project is. So what is long-term infrastructure depends partially on the industry, but I think it's fair to say rail is long-term infrastructure. Please forgive the examples that I'm giving as they're all linked to me personally in some way. I grew up near one of them and have used others as a commuter and worked on one of them. But the long-term infrastructure, the Liverpool to Manchester Intercity Railway is approaching 200 years old, and they're all still in use today. All original parts, all of these railways are still running on some of the original infrastructure. That is long-term infrastructure. We also need to be forward-looking. So with the long term in mind, we need to plan for decades, not just years. We need to look at what will the market be? What operationally do we need in 5, 10, possibly even 20 years' time? What will passenger journeys look like? What data sharing do we need to do? What sensors do we need to build in, or what provision should we make for those? Can we have predictive or prescriptive maintenance? So we use whether it's machine learning or statistical process management to look at when do components need to be replaced, when do systems need to be repaired, and how do we do that in an efficient manner. There's also new developments. So as I'm sure everybody knows, there are increasing um, pressures on alternative energy, electric vehicles, autonomous vehicles as well. There are things that we have to keep in mind, such as, for example, car parking to support electric vehicles. The car parks typically have to be stronger than they are at the moment because electric vehicles are typically heavier. There's also the concept of the physical internet, which we'll return to as well. So with all of those in mind, we have to think, what will the market be in a decade? What should we put in place now that will support those futures? We also think, how will things be run? How will operationally things be managed? Signaling and control has to be designed to be flexible for the long term. We need to think about how will the infrastructure and the railway operators interact? How will data be shared? Is it possible to have unified ticketing or unified journey planner for a journey that begins, for example, on a ferry and then is rail? Can we link, as we connect airports together, can we do unified ticketing for air and rail? What about baggage handling for that scenario? Same for ferries. For freight, how do we manage the interaction between the freight user, the freight owner, and the potential consignor or the logistics provider? How do we integrate that data for them? And can we offer open data services so that third parties can develop their own apps or their own portals based on live data feeds or semi-live data feeds? And that brings up standards. And you'll see that I return to the theme of standards quite a lot. The most important thing that we have to get right is to make sure that the standards we adopt are going to be flexible enough for the future, that they will provide what we need, what we think we need, and have space for expansion or extension. For stations, for people, we need to look at efficient services, and that's not just train information, but also potentially load level indication. So if you look perhaps at the middle picture on the right, you'll see an indication of how busy each car in that train is. Guide passengers towards the lighter loaded cars, make it easier for them to get on and off. That actually helps with railway efficiency as well, because it means it's less likely the train will be delayed by passengers entering and exiting vehicles. We can look at things like crowd and flow control monitoring. Whether that's done with CCTV or whether it's done through radar or LiDAR will have to be worked out. It's possible to use either approach. It's possible to use both approaches. What other services can also be added at stations that will provide extra value for people? And how do we make sure that we keep those opportunities open? If we have locations, and we have quite a few, where there will be multiple transport modes, can we display in the station the transport information for those other modes? Can we do an integrated journey planner across transport modes, as I mentioned? Is it possible to do single ticket? There are standards available. There's a family of standards called Transmodel, which will support all of those applications and also supports future applications, such as, for example, when you book the train ticket, you could reserve a car parking space. We have to look at whether those standards are mature enough to implement and whether or not they meet the use cases that we think we're going to have over time. For freight, there are a great deal of services that could be offered. So that's shipping container, whether it's 20-foot equivalent or 40 or even 45. It's Are we supporting trucks, whether they're accompanied, so tractor trailer with a driver, or unaccompanied, just the trailer? Can we look at express small freight? So, for example, e-commerce deliveries, parcels, and things like that. If you look at projects in Italy, in the UK, and some other places, um, typically they're looking at using converted passenger trains as express freight for small items. So perhaps a rolling cage with parcels in it. The Italian example is actually interesting because one of the things that they're doing is using um, chilled rolling cages to move fruit and vegetables, but also secure rolling cages to move pharmaceuticals. So not to parcels, but other express small freight. From an infrastructure point of view, that becomes interesting because the same infrastructure for small freight could also support passenger luggage and similar options. So they're the kind of things that we can look at. I mentioned autonomous vehicles. So one potential future scenario is an autonomous last mile truck, maybe a 20-ton truck, for example, that is able to drive itself to a rail freight terminal, drive itself onto a train, drive itself off the train at a destination, do its last mile loop, and then go back to the station and travel on. Those kind of scenarios are some years away, but if we're thinking of them now, we can make sure, or at least we can try to enable those services in the infrastructure. We also need the services to be scalable so that if, for example, a particular service becomes more attractive than we can forecast at the moment, then we don't need to reconstruct freight terminals. Perhaps we also want to scale things down and offer regional freight. That might become particularly relevant if you have electric last mile trucks and for small freight. And again, we need to think about interoperability across transport modes. If we have a service to enable passenger cars to be transported, that's a sort of freight in that similar approach can be used for freight terminals, for trucks, and for cars. How do we do integrated planning across the transport modes? And then, as I said, infrastructure support for electric vehicles, alternative fuels. All of these things will come down to what standards can we use. Overall intermodal integration, we need to, obviously we aim for efficient services, high utilization, unified tracking and status information where we can. We'll look at, can we synchronize the modes? So if any of you is familiar with a organization called Alice, they have a concept of synchromodality, which means that all of the legs of a journey are synchronized. So when a container, for example, comes off a ship, the train is ready for it, or the truck is ready for it, or the aircraft is ready for the LD3s. What value added services can be added? And at the moment, we probably can't foresee all of those value added services. So how do we keep the door open for those things for as long as we can? Intermodal operability is going to be key, and it's going to depend on data services and visibility across those transport modes. Our stations, our freight terminals can be seen as transport hubs for multiple modes. We need to think about onward distribution. So what do people do after they get off a train? What happens to the freight after it's unloaded from a train? What's the last mile? How do all these systems talk to each other? Again, we need to look at standards. And some of the standards for freight can be reused for passenger services. Some of the standards for passenger can be reused for freight services. It's what we'll have to do is look at partner organizations, other railway entities, other transport modes we can work with to make sure that those things are as flexible as possible. For maintenance, obviously, if we're looking at long term, we need to think about the life cycle of the assets. That's condition monitoring, real-time information. We'll look at predictive maintenance, prescriptive analytics, and the reliability engineering. Make sure that the infrastructure is as reliable and as sustainable as possible. We also have to think about doing that across multiple organizations. So Rail Baltica is one project, but obviously in the operational railway, there will be multiple organizations involved, multiple railway operators. The infrastructure will have multiple maintainers, managers, and suppliers for those maintainers, managers. There are obviously the regulators, the safety authorities, emergency services could be involved with data links at times, and we need to think how do we best manage those. So again, we're looking at what standards are appropriate, what standards can we use. All of these things are driven by data. Digitalization for the railway. I'm not going to talk through this whole slide because it takes quite a long time, but you'll get a chance to ask questions at the end. We will be returning to this slide. This is just to give an idea of the number of different systems and families of systems that have to be considered. One box on this slide is not necessarily one system. Some of those boxes could be 10, 15, 20 different systems behind them, all of which have to be integrated, all of which have to be able to talk to each other. So we're coming to the first of the audience polls. It's been said that innovation and digitalization are two sides of the same coin. So could you please rank the options that are presented, whether that's reduced emissions, whether it's increased efficiency, whether it's widening the supply chain, creating job opportunities, or whether it's the new range of new services that could be implemented. So how do we address those things? So I'll give you just a few minutes to answer that. Thank you. Okay, increased efficiency is going up, as is supply chain. We will share the results of these polls after the event has ended. Um, Unfortunately, I can't share them live. Okay, thank you. I'm going to close the poll now in just a minute. Okay, thank you. The increased efficiency won by quite a long time, by quite a long way, but then the second was supply chain. So that's a good information for us. Thank you. We will definitely be looking at the results of these things as we're planning sort of work going ahead. So we have to think of the wider perspective. This is, as I mentioned at the start, this is a European project. We have to look at what work is being done elsewhere. So there is a centralized body called Europe's Rail Joint Undertaking, which is the successor for Shift to Rail, which is centralized and coordinating all of the European rail research. It's formed of multiple managers, multiple operators, multiple suppliers from all the way across Europe. So people like Deutsche Bahn, SNCF, the UK's Network Rail is in some projects, the Traffic Raquette. On the supply side, most of the big industry suppliers are involved, and they have quite a few things that are directly relevant for us. So the most important is a thing called the system pillar, where they're looking at a common architecture, a common structure for how railway systems are integrated and how those systems all talk to each other. So we're returning to the theme of standards, of data exchange. A lot of work is being done under the system pillar, under a project called Links for Rail and another one, X Rail. Those projects have provided a great deal of information for us. We are, for example, looking at an architecture that is very similar to the system pillar for our signaling and control. The slightly complicated diagram on the right is how the system pillar itself is structured. So you'll see they take into account things like the energy supply, um, the management of passengers, uh, asset management and maintenance contractors, and also things like overall operations, traffic management, telematics, so the sharing of data across modes and across the organizations. That ultimately is aiming to lead towards the single European railway area, which is analogous to the single European sky. And the intent is to have a common data model that railways can use with secure data exchange between railways, particularly for cross-border, and an approach based on a concept known as Rail CDM. So that CDM has emerged from the aviation sector with collaborative data management. And to give you an example of, a view of where that came from, if you can imagine the number of stakeholders involved in an airport, collaborative data management is the approach that is used for them to work together. So airport CDM allows, for example, a retailer to integrate into the airport systems. It allows an airline to inform air traffic control, but also to inform airport ground staff. Are there any delays? Are there any issues with aircraft? Are there any holdups with particular passengers and so on? So that approach has already been studied for potentially for rail freight. The question is, can it also be used for rail passenger? And can it be used as the basis of integrating different transport modes at hub locations? It won't surprise anyone to see that that is all based on standards. So another big project or another big effort that's happening this time at a global level rather than just European is a thing called the Future Railway Mobile Communication System. So I mentioned at the start, we are going to be using the European Rail Traffic Management System, ERTMS, with intention is FRMCS. The reason for that is the existing system is GSMR. It's 2.5G and it's planned end of life in 2030. That's not long-term viable. FRMCS specifications are being finalized, but the key things is that unlike GSMR, they are not specific to the railway sector. The features that are being needed for FRMCS are being built into 3GPP specifications. So when you hear 5G, potentially 6G, these features will be included by then. The GSMR feature set is the base, but there are additional features being added to take advantage of things that have come in with 5G. And which version of 5G will depend on which features we get. There will be bearer flexibility, so the onboard system will be almost independent of the telecoms network. We also need to think about the spectrum, the radio spectrum that's available. It's dedicated for railway use. There are two different spectrum windows, and they are different in range. They're different in the way they're implemented, and they're complementary in some cases. So it may be that the higher frequency, which gives you lower range but higher bandwidth or higher data rates, can be used in places where there is more traffic, or can be used as supplemental, so the two frequency spectrum used at the same time, the same place. For the onboard systems, it's modular and it will support multiple bearers, so it can support multiple radios. Sorry, excuse me. One interesting thing that means is that as 5G evolves into 6G in 2030 to 2035, the onboard system can have the radio replaced without needing the rest of the systems to be replaced. That is not typically the case with GSMR. So this approach is better for future-proofing. It's better opportunities in the supply chain as they're no longer big monolithic systems. Other companies get a chance to specialize in particular areas, and then typically a system integrator or a large supplier would put those components together. So that modularity gives us a bit of future-proofing as well. There are also, as well as the EU and the International Rail initiatives, there are quite a few industry initiatives with groups or organizations getting together. So you have EU Links, which is a data exchange standard for controlling elements of the signaling system, which is basically a collaboration between multiple infrastructure managers and some suppliers. You have the reference CCS architecture for train traffic management and train control, which is being run by the ERTMS users group, which again is multiple organizations, infrastructure managers, operators, and suppliers. And then there's the Akura consortium, which is looking at the onboard reference architectures. Again, that's multiple suppliers, managers, and operators, including rolling stock suppliers, its onboard system. There are also individual national projects, which we believe we can learn lessons from. So there was Smart Rail 4 in Switzerland, Digitalization Deutschland in Germany, Digitata in Finland, and the UK's Target 190 Plus. All of them have interesting features that we can look at. So for example, Target 190 Plus is looking in detail at digitalization of design steps and of testing so that things can be tested, simulated and tested digitally rather than having to wait for things to be physically built before they can be tested. That's clearly an opportunity for some saving of time and therefore cost. Digitalization Deutschland and Smart Rail 4 both looked at, can commodity IT and commercial data centers be used for railway equipment? Do the standards, particularly the safety standards, allow that? The answer as of 2023 is no. They're not quite there. What we don't yet know is will they be there in time for us? And that's something that we're actively looking at the moment. In some cases, it may be possible. In others, it might not. It will come down to the applications. But if you can imagine the railway as a whole, there are a lot of systems that are not safety critical. There are a lot of systems that are not train control or traffic management. So those opportunities exist there. We also have the opportunity to look at what sensors are available, what's new, what's upcoming, what's been modified or enhanced with new technologies. So for example, RFID tags can be used for vehicle ID. We can look at weighing in motion or wheel impact load detector to see how heavy is each wagon. And depending on how that's configured, that's potentially a source for how busy is each wagon in the train. So a passenger information display. Maybe that's not the best way of doing that, but it's an option. It also allows us to detect and then notify the railway operator, the undertakings, if there are any particular kinds of wheel faults. So if you can imagine a heavy freight train with a wheel that's damaged, that will have an impact on the infrastructure, and it could make it more dangerous for following trains. Weighing in motion has the potential to detect shifting loads. So if a load in a freight train is not secured properly and it moves, that's clearly a big risk. That's clearly a derailment risk, depending on how much the movement is and what the load is. So we need to think of those kind of things. We can also look at thermal sensors and vibration sensors. So hot axle box detector to warn of bearing failures, again, to warn of potential derailment or other failures. Dynamic response analysis can also give early warning of wheel set issues or bearing issues. We then also want to look at the environmental sensors. So, for example, the train operating speeds may have to be changed depending on the weather. Or if there's a lot of snow, if there's a lot of ice, what impact does that have? Let's make sure that we know. Let's look at video to see how crowded is that station platform. What's the hazard plate on the back of the freight train? What materials are in it? And then we can look at a whole range of Internet of Things sensors. The quick question with those is mostly how do you integrate them, because they're all slightly different. There are also continuous sensors. So for example, distributed acoustic sensing with optical fiber along the side of the track will again warn us of some kinds of wheel issues, but it'll also tell us where the trains are and the speed and the direction and a lot of other parameters. The good thing about those continuous sensors is you can have maybe one sensor node every 40 or 50 kilometers covering 100 kilometers range. You don't need to put sensors every few hundred meters. So the sensors themselves are more complicated, but they cover much greater range and they're passive. Apart from that one sensor node, there's no need to put power out to individual devices. So there was no need to, for example, to have maintenance crews going out changing batteries for these kind of sensors. And that could also be applied to temperature sensing as well. Again, we have to look at how do we integrate all of this data, how do we process it, how do we visualize it so that people in the control rooms can see what's happening and maintenance crews can see what their workload is likely to be. And again, that will be open standards. There's also an area known as auto ID, which is having identification numbers for things that can be read by machines. So the identification of whether it's a vehicle, whether it's a component or an assembly of components, or whether it's of a location or a particular kind of freight, those labels can be harmonized. So if you look at, for example, uh, the image on the right, you'll see, three different railway organizations all wondering, are they looking at the same part or not? Are they looking at the same uh, train, the same fault on the same train? Are they looking at the same fault but on different trains? And if so, are there any lessons learned that can be exchanged? And that's again, multiple organizations. It's also possible to use that to track the location of a train. So I mentioned the sensors can detect potential wheel faults, for example. RFID asset identification or similar can say it was this vehicle, this specific wagon number, and inform the maintainers, be ready for when this comes in because you're going to need to do something. All of these identifiers, all of these auto ID labels are ISO standards or similar, and they're all, again, open. So we can look at using that technology, if you can imagine that expanded real-time tracking of whether it's a loco with wagons, whether it's a multiple unit train, whether it's a shipping container, or whether it's something smaller. Maybe it's a rolling cage, like I mentioned, for small freight. For maintenance, you could use the auto ID keys to look up the service history of a particular asset, or to find the documentation or safety procedures. Potentially, you could do a worker ID system based on that as well. And in the service history, know who the maintainer was for a particular asset at a particular time. All of these are based on open standards and ISOs. So with all that potential data coming in, we have to think about, how do you manage that data? How do you analyze it? How do you store it? What's the most appropriate storage? So there will be streaming data, so real-time position, for example. There may be files describing design. There may be some things in relational databases. There may be some things in graph databases. The perfect example of perfect use case for a graph database is actually railway. It's linear assets connected to each other, and the connections and the directions are key. So how do you manage that? What are the key factors that we need to think about? All of these data sources will be different. There will be domain-driven patterns. So the experts in a particular field will have to be involved in, how do you manage the data for that field? What follows on from that kind of design pattern, is, can we have self-service analytics so that an asset manager can look at all of the data available about that asset and come up with their own dashboards that tells them what they need to know on a day-to-day basis, rather than them having to go to a data science team or hire an external contractor to come up with things for them. Is it possible to make those analytics easy enough and configurable enough that you could have that kind of self-service? You also, though, have to look at the governance of the data. Who is allowed to see what, under what circumstances, what authorizations are needed, what has to stay within national borders, what has to stay within the EU, what can be in a cloud service, what can't. And ultimately, you're looking at, data as a product with a defined specification, a defined interface, probably a defined service level, and all those kind of things. Open standards will support open data, and that will support the full digitalization. So again, looking at digitalization, we have to think digitalization is the enabler for most of what we're talking about this afternoon. But it's not just digitalization, it's standards-based digitalization. And with that, we come to the next poll. So of the things that we've just gone through in terms of European projects and international projects, how would you think they rank? How do you think their relative importance should be ranked. So let's open the poll. Okay, I'll just give you a couple more minutes. We have some responses coming in. At the moment, the common objective and process for single European railway area is lead, followed by supply chain. Okay, I'm going to close the poll. So thank you, everybody. We have common objective, single European railway area is the highest, followed by supply chain, and then opportunities from the greater use of commercial IT. So thank you very much. That's useful info. So we talked quite a lot about digitalization and the opportunities and what's in the supply chain. Obviously, that's extensive use of IT. We also have to think about sustainability. This is a greenfield project in 2023 to 2030, not something that's been in place for years and years. So what lessons can we learn from other people about sustainability in IT? So there are huge data centers out there run by people like Google, AWS, Azure, um, Meta, people like Comcast in the US and so on, as well as the telecoms industry. And you can imagine just how big their electricity bills are, for example, or their heating and cooling bills. So what lessons can we learn from them about more sustainable IT? Things like, can you reduce the amount of plastic? Can you have better cooling? Can you have better airflow? Can you get more systems into a given rack of equipment by, for example, having a shared power supply shelf that supports multiple servers instead of individual power supplies in every single server? So you get better use of space, better cooling, better efficiency, and a lot of flexibility, a lot of shared resources to think about the life cycle and reduction of the use of plastics. You'll notice, for example, that of those servers in the image, none of them has a plastic label on the front. None of them has a manufacturer's bezel. What's hard to see in the image is where there are some blanking plates. So the rows of 3 white boxes in the left-hand rack, for example, those are actually treated cardboard, not plastics. They are all recycled. A lot of the machines themselves, in this image anyway, a lot of the machines themselves are late life machines. So some components have been recycled. And there are lots of flexibility in the supply chain. If you look at the hyperscaler lessons, they've all designed specifications jointly and they release them to the market so that anybody who wants to design or build to that specification can. So you often see, or you might well see a rack with suppliers, with multiple suppliers of the same equipment in the same rack, the same specification, just come out of different factories. A lot of flexibility can be built in. The other thing we can look at is standards that have emerged over the last few years. So some of you will probably have heard of the idea of tier 3, tier 4 data centers, about the availability, the level of redundancy, and so on. The tier system is often interpreted slightly differently by different people. And with that in mind, there's actually a Euro norm 50600, which covers availability, reliability, maintainability, and sustainability. So for example, availability class 4 under 50600 would be tier 4. But there's then the reliability, maintainability, and environmental sustainability aspects of that class as well. There's ISO 27001 for security, and there's also a data center KPI, a key performance indicator standard, 30134. A lot of those things apply at data centers. Some can be scaled down to smaller locations. Some are really only relevant if you're at the massive data center scale, with 1,000 racks, not 10. However, there are lessons learned, and there are considerations in those KPIs, for example, that we could adapt as KPIs for a smaller site. So the main factor to take away from this is that those systems can be made by multiple people because they're open specifications. They're designed for efficiency. They're designed to reduce power, and they're also designed to be completely lights out. So all maintenance is remote wherever possible, unless it's physical component swap out. And when it is physical component swap out, these designs are all toolless. Almost every component can be swapped without needing any tools. Obviously, in most cases, you'll power down the machine before doing that. And when you look at powering down machines, you have to think what happens to the workloads. There's also other things within the modern IT approach. So there's a lot of networking equipment with disaggregation. So the operating system and the hardware come from different places, or can come from different places. That is key if you think about the long term. You can replace the hardware without having to replace the software. You can upgrade the software without having to change the hardware. You don't just have to have whatever version of software a device manufacturer thinks you should have. You don't have to buy, if you want a particular feature, you don't have to buy a particular box. You can mix and match, and that gives much more flexibility for the future. It also means some features can be done on commodity IT. So some features that in the past would have been done on a dedicated hardware appliance now can be done in software with containerized software or virtual machines acting as if they were the appliance. That cloud native software approach we'll come back to, but it gives us the opportunity to look at simple range of hardware, a smaller range of basic hardware with task-specific accelerators. So without going into who is who on this, in the images you've got a gateway, you've got a couple of servers, there's a storage server, and in terms of add-in cards, there's a network accelerator, there's a storage card, and there's a 5G accelerator card. The storage card is an interesting one. If you think about the amount of data we're going to have to manage, people are very concerned that it'll just be too big. How much power do you need? How much storage do you need? How big is a physical drive? That storage card that's in that image is able to support up to 168 terabytes of data on that card. The server in the middle on the right is able to support 480 terabytes in one server. So in terms of modern approaches to IT, things have changed. It's not necessarily big arrays of disks, rooms full of tape libraries. Again, all of these options, all of these solutions are available from multiple sources based on standard specifications, based on common spares in some cases, and where you have a server plus an add-in card, clearly if the server fails but the add-in card is still working, you can swap the add-in card to a different server. That's all enabled by using standards that everybody can access. So we mentioned cloud computing, and there's also obviously with 5G, people would have heard of edge compute as well. So the edge compute use cases in rail are mostly to do with either real-time alerting, a dangerous parameter has been detected, or an out-of-range parameter has been detected, or for some analytics at the edge, or simply for data volume reduction. If you have a sensor that's generating 2 or 3 terabytes a day, do you really want to backhaul all of that data to a data center? Probably not. Is all of that data going to be useful? Probably not. Can you extract the relevant features, move those in real time if you need to, or move them in near real time otherwise? And then maybe use a backup process to get the rest of the data, because it's possible that by storing the data in 3 years' time, in 10 years' time, someone may come up with a new algorithm that can be used for data mining or machine learning on the data and add value that we currently don't know is there. So that's an edge node. They could vary in size, they can vary in location, and they can vary in hardware. But the key thing is, how do you manage them? What is the architecture that you use? How do you layer things together? So there are clearly multiple layers involved, whether it's edge, whether it's a private cloud, which could be in a railway data center, or it could be in a commercial data center, or whether it's a third-party cloud. Perhaps some data needs to be stored in government cloud. Perhaps some data can be stored in a commercial cloud service provider, in AWS or Google or Azure, for example. How do you maintain those things, and how do you manage them? And how do you have uniform management across those things? There are standards that can be used for doing that. And again, this is hyperscaler lesson and it's telco lessons. How do we apply those in our environment? We also think, how do you roll out all of this equipment? How do you manage it? How do you maintain it? So one key tool, and again, I won't go through this slide in detail, through the graphic in detail. It's for network equipment, but it applies as well to everything else. We can look at zero-touch provisioning. So a device or a box is shipped to the site. The installation tech on site installs it, connects it, powers it on, and the device downloads its own OS and configuration. There is no local configuration done. For management, for support, everything is centralized, whether it's alerting or logging or security monitoring, it's all centralized. So we cut down on on-site support and remote field working. And if a box goes wrong, you drop ship a replacement and just repeat the process. Or just, if it's a software corruption, reboot the box, reprovision it. All of this is possible using standards that already exist. So if we put all of these things together, we end up with a data-driven railway. So dashboards, maps, monitoring, efficient, flexible systems, driven by standards, driven by published and shared specifications, horizontal scaling. So instead of buying bigger and bigger boxes, you just buy more. Common spares across those boxes. Cloud native approach to deployment. So workloads can be moved across boxes as things need to scale. What lessons can we learn from other sectors? We've talked quite a lot, or I've talked quite a lot about hyperscalers, but in terms of the sensors and sensor networks, what can we learn from, for example, the oil and gas sector? What can we learn from Internet of Things companies? Telco and IT lessons, I think we've covered quite a lot of. There are some similar things that we could learn from energy. There's also some interesting things that we can look at from retail. If you think of a retail organization with maybe 20, 30, 50 different outlets across a country, how do they manage their IT? Is that fundamentally different from how you manage the systems at a station? Is there something interesting that we could learn from them? Is there an interesting approach that could be taken to manage retail outlets within stations? So let's be open to those lessons. And the most important thing, again, as I mentioned at the start, pretty much a theme, open standards wherever we can. If the standards exist, let's use them. Let's not create new railway specific specifications. Let's have a connected railway with standards as the base, with modern IT, with all the design data, with flexible systems, with as-built data on top of the design data. And then when things are running, we add operational data, and overall, a digital railway. And that's the end of the presentation. So I think we're moving to Q&A. So we have quite a few questions. Thank you very much, everybody. Let's look at. So we have two related questions on FRMCS. So I'll take both of those first. The first is, how mature is the market to deploy FRMCS in a greenfield project? Do we have a plan B? And which version of 5G will be used? So for In terms of the maturity of the FRM specification, that is something that we are actively monitoring. We're involved in a international rail project called 5G Rail, which is helping put that specification together. The majority of the specification is already in place within the 3GPP releases. That's linked to which version of 5G will be used. Release 17 has a lot of the features that we actually need. Release 18 has most of the rest. There are a couple of things that are nice to have that will be in release 19, but the release 18 brings in some new things as well. So I mentioned that there are the two frequency bands. One thing that's an issue at the moment in the release 16, 17 spec is how do you have, if you have GSMR and FRMCS in the same frequency band, how do they interoperate? Release 18 is addressing that. So there will be some potential scope for coexistence or for easier coexistence. In terms of is the market ready? The feedback we have from a couple of suppliers is they are not ready in 2023. They expect to be ready in 2025. That will depend on the standards track happening. But the standards that we need in place, the rest of the standards that need to be in place are due to come in during 2023. So as long as there are no major delays on the standardization track, then we're on course for FRMCS. So let's look at. So and it's popular to create digital twin to help maintain and manage infrastructure. Is the digital twin planned or being developed? Sorry. Yes, we are looking very closely at how we do that. So in the final slide, I showed that the as-built data layered on top of design. That will actually, that plus the operational data will effectively give us a digital twin. One thing we have to look at is how will that work in practice? How will the data governance work? What data is accessible to whom? And that will be a piece of work going forward over the next couple of years while systems are being designed. Do we as RB Rail AS actively participate in industry initiatives and other suppliers initiatives to keep in tune with opportunities? Yes, we do. We are not necessarily a formal member of all of those things because most of them are for operational railways. We're implementing. So we're not quite at the same position as most of the members, but we are monitoring most of what's going on. We have close ties to several external organizations. We've had some in-depth discussions with people like Deutsche Bahn on Digitalization Deutschland, with contractors working on T190 Plus, with the DigiRail team in Finland, and so on. So we are actively talking to people and seeing what can we do, what's in the pipeline, what do people think will be done over the next few years that we could build into the greenfield. What IoT sensors, noise, weather, and air quality are we planning to establish near the Rail Baltica track? That's under review at the moment. That level of detailed design is not where we're at today. In terms of what sensors are deployed, we'll look at what's necessary for the railway first, and then look at what the other options are and what will fit within timelines, what fits within budgets and capabilities. Are we planning to share all this data as an open data? We will use standards where we can, and we'll use open standards where we can. There is a big line between using that and sharing everything as open data. I'm not in a position to say yes or no on this. My own view is that we should share what we can, as long as it doesn't have any impact on the operation of the railway. So I think that's watch this space. We hopefully will have some more information on overall direction over the next few months. Can we expect Rail Baltica to expand the current scope for health management to allow other components. Um, yes, we can look at other monitoring solutions to help rolling stock, and not just wheels and axles. Wheels and axles are just an easy example to use. I think everybody understands that if there's a fault with an axle, there's a fault that the train could derail. Um, and also writing the cost or studying cost benefit for those kind of sensors is quite clear. So, for example, I saw some information not that long ago where the cost of a derailment in the UK is typically taken as 10 to 18 million euros, well, by the time you've converted it. Um, and if the cost of the sensors is, let's say, for example, a million, and you manage to prevent one derailment a year, that's a pretty good cost benefit cost ratio. So it's I know I focused on wheels and axles. It's just the easy example to use. How big is the cybersecurity challenge in the digital rail scenario? Um, it's significant. There are some unique challenges, and there are some challenges that are also faced by other industries. So there have been some specific cyber attacks on rail. The best example I can think of is San Francisco Bay Area Rapid Transit a few years ago lost control of their ticket machines, and they had to run local metro services in the San Francisco Bay Area had to run for an entire weekend without being able to collect any money from passengers. That cost them a significant amount. So that's a transport case. We are looking at that. We are also aware of particular regional concerns. Those things are being looked at. There are specific railway cybersecurity standards, and I believe there's another one coming out later this year, or an additional one and an updated one. There are also, I mentioned the data center standards. There are a family of cybersecurity, or there's a group of cybersecurity specifications within the family of data center standards, not just 27001, but things like physical security and the cybersecurity aspect of physical security. So, for example, making sure people can't hack into the CCTV, or the access control system for a data center and so on. So, yeah, there are significant challenges, but we're not on our own. We are working with others to see what can be done. What's the most efficient way of doing that? And I'm just looking at the time. I think there's probably time for one more. Um, so I'll take one, or actually two more. There's just time. If we're speaking about open standards, would it make sense to join EU links for interoperable train control standards? We are we are looking to embed EU links. We can do that without necessarily joining the EU links consortium, but we are looking to embed that. And last one, does the auto ID approach mean uniform component labeling so suppliers have guidance on what we would expect? Yes, that's the intention at the moment. We will look at a single approach, try and have uniform standards based on, for example, ISO 15459 for component ID and labeling, and we're intending to publish supplier information as procurements are launched. So I think we are out of time, or very nearly. Can we expect Rail Baltica to be operational in 2030? This will have to be a final question, I think. The intention is that the railway will be implemented in stages from 2027 to 2030. So can we expect Rail Baltica to be operational at 2030? That is the intention as I say this. So I'd like to say thank you very much for everybody, whether you joined us from LinkedIn, from YouTube, from Facebook, or from our own website. If you want more information about the project, please go to railbaltica.org. If you're a supplier and interested in the procurement processes, please go to railbaltica.org/tenders, and you'll see open and also historical tenders. So the archive for tenders may give you some information or give you some feedback on how we tend to run procurement. So that can be useful for people. Sometimes people learn things from there that we don't see, or we get Q&A, and a historical tender would have said. So again, thank you very much, everybody. And I think that's that. Have a good afternoon.